Welcome to a lesson with Dr. Powell. Let's take a look at how the Smith normal form can actually tell us a lot about whether a map is injective or surjective. So suppose that our Smith normal form is something like this. 1, 1, 0, 0, 0, 0. Okay, our kernel has dimension 1. What does that mean? That means every single fiber of the map is actually a coset of that kernel, of the preimage of the zero vector, which is a column. This actually, every single fiber is, so F inverse of anything else, is actually just a shift of this. And that's because this is going to be a subgroup of the domain, and the cosets are simply shifts, or the cosets which are shifts are the fibers. So now, in order for it to be injective, that means that each fiber can have at most one thing in it. But wait a minute, this has dimension 1. That has many more things in one, so therefore it's not injective. The only way to get a map that's injective would be something like this, so that your kernel has dimension 0. If the kernel has dimension 0, that means that the zero vector is the only thing in it, so there's only one thing, and so that means that every fiber, which is a shift of one element, has only one thing in it, therefore the map is injective. So now, the kernel, which is the fiber over 0, being 0, is the same thing. Kernel equals 0 is the exact same thing as the map being, or the function f being injective. Okay, now how can you tell if it's surjective? Well, we simply need, in that case, for the number of, so think about the row space. The row space, or kind of how many different, what I mean is how many different elements do we have in the image? So the number of rows is what I meant to say. The number of rows looks like we're mapping to R2 in this case. So R2 would be the codomain. Now, if R2 is the codomain, take a look at the dimension of the image. The dimension of the image, or the range, is 2, and that fills up R2. Therefore, it is surjective. So if there's ones going all the way down to the bottom line, that's surjective. Here, this map is not surjective. Notice how the ones don't go down to the bottom line. The codomain is actually R3, but the range is actually isomorphic to R2. So a two-dimensional subspace of R3, and we can't have that. So that is, so in this case, this would not be surjective, but this one is. So so if the ones go to the bottom, it's the same thing as it being surjective. Thanks for watching.